Alright, B-Spline Curve Human Created CAD Lab, May 21st, 2009. This is the Seoul National University Computer Aided Design Open Courseware Lecture Notes 19. B-Spline Curve Human Centered CAD Lab, May 21st, 2009. Properties of the B-Spline Curve, the B-Spline Curve, the degree of the curve, with an independent number of control points, preserved curve, global modification, any one of the control point changes the curve of the tree with everywhere, all the blending function for the non-zero value in the whole intervals of the 0 to greater for the u degree, the u is greater than or equal to 1. Preserved curve, global modification, preserved curve of the degree. Curve of the degree 3. Desired blending function, considered degree blending functions in the nth to fourth. Resulting curves, similarly, blending function, considered 2 degree blending functions nth to fifth. So we have these different blending functions of the curves and their effects. The result curves, 0.1, 0.2, 0.3, 0.4, 0.5, and we use different radius curve. These are the points of the resulting curve. A B-spline equation. Degree of the UK, independent number of the control points of the knots value of the boundary to non-zero range of the blending for the total number of knots and of the independent number of control points values. B-spline curve and an equation. Only difference in the knots is important as B. Can be shifted. The whole parameter range should be shifted together. The portion of B-spline curve that's effective limited number of control points. The control points associated blending function non-zero to T plus 1 have the effect, and 1 0 non-zero of the men. Substitute M1 right hand side can be non-zero. Apply recursive from the non-zero B-splines. Control points have the influences of the region. For the control points modify examples. Alright, the knot, or T0, T1, Tn plus K of the parameter range determines the knot. Periodic knots, and non-periodic knots. Duplicates of knots times duplicate knot times. Periodic versus non-periodic. Periodic knot. Non-periodic knot. B-spline curve knots. By duplicating a knot, K times at the end of the curve pass through the first control point, last control point. Periodic knot, first control point, last control point do not pass the curve of the other control points. Non-periodic as do not pass through curve as other control points. Non-periodic knots are U. The most CAD system knot intervals is uniform, and D uniform B-spline, non-uniform B-splines during manipulation curve shaped knots are added or removed. Non-uniform knot, non-uniform B-spline curve. Knot insert example 1 and 2. Example 1. Example expansion curve equation. Considering reserve define non-periodic B-spline curve not ordered control point in preserve curve special case B-splines for curve example. Example continued. Example continued. Example continued. Example continued. This is just not really showing you any CAD, but the solution. The example continued. Similarly, example continued. This is more of around the points where they touch and intersect on the line. Least squares curve approximation interpolation. Determine parameters, values, corresponding data points. Calculate control points. Least squares curve approximation 1 equal variables parameter 1 parameter number of minus 1 parameter 1 can be 1 to the n to minus 1 9 n to the 1 equations and the n to 1 variables can be generated. Alright, intersection between curve with the initial value of the u and v of the total from the real solution of the iteration diverge is hard to find. All intersection points cannot handle the case of the overlapping curve of the two curves that regarded intersect with each other. The other lie within numerical tolerances. Control polygons approximate with the curve of the subdivision. Initial value of the UV can be provided with the closely intersecting control polygons better to detect special situation bands before restoring neutral solution tolerance. Tuning tolerance values is necessary. Straight line versus curve, and then non-uniform irrational B-splines or NURBS usually have blending functioning as a B-spline. Control points are given in homogeneous coordinates. Non-uniform rational B-spline curve that passes through the first last control points by a non-periodic nonlinear U. The numerator B-spline with is H1, HI and PI control points, H0, P0, HN, NP parameter boundary values. Similar to the denominator with the values H0 and HN with the parameter boundary matters. Direction with the tangent vectors, all starting at endpoints. B-spline curve in the case of the NURBS. Non-uniform rational B-splines. Curve shape of the chain with the change of the weight. Increased weight of the effect of the pulling of the curve toward associated control point. Counting curve with the represent exactly reducing program coding effort. Control points, nerves, and examples. Composition. And I'm sorry I didn't want to read all that mathematics, but play around with it with AutoCAD. This is B-spline curve human-centered CAD laboratory. May 21st, 2009.